Most people don't realize that natural gas, when it comes out of the ground, is contaminated 10 to 20% by CO2, and sometimes in some parts of the world as much as 70% of the natural gas coming out of the ground is CO2. We want to take that CO2 and just send it right back down hole where it was, right at the wellhead, so we don't have to just vent it to our atmosphere and deal with this greenhouse gas in the atmosphere. So the way CO2 is presently separated from natural gas is it goes through a tower of an aqueous amine. Aqueous amines are corrosive, and the platforms are very large for these. So you have a large aqueous amine tower, and you bubble the natural gas and CO2 through it, and it reacts with the CO2 and holds it in there. Then you turn it off, and you have to then heat this aqueous amine tower up to 125 to 140 degrees centigrade, which is a huge energy cost to do this. And then you can remove that CO2, but that's happening at a natural gas collection site. And so there's no convenient way to deal with that CO2 now that you've trapped and now is vented, so it's generally vented to the air. Plus the footprint, the area of the aqueous amine tower is extremely large. So it's energy intensive, and it's space intensive, and it's corrosive. So what we've come up with is a material that is very simple. It's a carbon-derived material, and we can make this from inexpensive polymers. And we just heat this up in a single step, the inexpensive polymers, with a base like potassium hydroxide, which is extremely inexpensive. We heat it up to 600 degrees, and out comes this black powder. This black powder will trap the CO2 as it comes out with the natural gas, and it will trap it. We can do this at the wellhead. Where it's coming out of the ground, we can trap it, and that way it's much simpler in an engineering way to take it and to pump it back down hole. But what's also attractive in this, whereas the aqueous amine tower only traps about 10% of CO2 by weight, this is trapping over 80% of the CO2 by weight. So in other words, 1 kilogram of this material will trap 0.8 kilograms of CO2. This new mechanism by which we found to trap CO2 could be enormous. What we're trying as humankind to do is to limit CO2 emissions from natural gas, from the burning, from flue gases, to be able to limit this. So if we can take CO2 and convert it into a solid, because the volume of a gas is very large compared to the volume of a solid. So if we can take the CO2 and polymerize it, then we have a large advantage in being able to contain it. At this point, there is no way to easily trap CO2 and trap it as a solid without going to extremely high pressures, which are totally unviable. But what we've been able to do now is at very low pressures be able to polymerize CO2. So this is going to allow us to trap it and maybe even contain it for hundreds or thousands of years as we learn how to now deal with it and react CO2 and use it as an important chemical for human use rather than venting to the atmosphere.